Hi everyone, and welcome to episode 2 of a brand new podcast from Teletrac Navman, Mobilizing the Future of Fleets. It's a podcast dedicated to helping fleet and transportation businesses navigate the roads ahead. I'm Barney Goffer, Product Manager for Fleet Energy Solutions at Teletrac Navman, and joining me today is a leading global authority on the subject of EV, Special Advisor to the UK Government, and founder of Zero Carbon Futures, Professor Colin Herron. Professor Herron notably spent 17 years at Nissan, where he was instrumental in the development and rollout of the Leaf, the world's first mass-market electric vehicle. Also joining us is Peter Crowe, European Sales Manager at Angie Energy Systems, a specialist in alternative energy solutions. Peter has worked within the compressed natural gas industry for 40 years in development, service and sales roles and across markets including Europe, Asia and North America. And today we're going to be discussing the future of energy technology. So I really want to start by kicking things off and the relationship between energy density and cost. And if you can take us on the journey of the electric vehicle battery in terms of where it was maybe 10 years ago to where it is now, and perhaps what the future looks like for it in relation to density and cost.
A long time ago, I mean, it was ridiculous figures. It was something like $1,000 per kilowatt hour. The target now is around $200. And the interesting thing is when I got my first, and it was a Nissan Leaf, a 24 kilowatt hour, if I got 86 miles, hey, that was good. You know, no charge points, 86 miles. People used to drive around with duvets and a shovel and a flask, you know, just in case. That's what we see now. What we believe we're at a plateau now. There will be tweaks of 10% here and there, but we're basically at a plateau on cost and energy density. The way people are getting around energy density now is they're just cramming more cells into a battery. So they're taking out unwanted space and sticking more cells in. That's where we're going.
So we're saying that it's going to get the batteries get heavier at this point then, or what actually happens if we put in more in?
Oh, they're getting heavier.
So what's the trade-off at that point then?
The trade-off is that the chemistry is getting better, but you can't sell the vehicle without the range. The next phase we go to is the solid state battery. The interesting thing about the solid state, if they go to the simple figures, is it's probably going to have twice the density and it'll charge in half the time, but it's expensive and we don't know how to make them.
Okay.
That's the problem.
Right.
What we'll probably see is when the cost comes down to it's a premium over the battery we've got now, it'll probably start to appear in those vehicles where cost doesn't matter. As the technology and the production goes in, it'll move down to your next class, your next. We'll probably see a price differential coming in. People will pay for this technology. Other people will not be bothered about and they just want the lower price vehicle. So it's a blend.
Is there an opportunity here to actually have different battery types for different use cases and different markets? Is that a scenario that's likely to play out?
That will come out. The question we've been discussing previously about HDV might be LFP batteries come. And there's other types of batteries which are being developed as well, which take out the lithium. So all of this is coming, but at the moment we're at a plateau, we're at a cost figure, and that's where we're going to stay for a little while.
So energy density is likely not to increase too significantly, but costs will come down over time. Is that what we're saying here then?
I think at the moment the answer is cost will come down purely because there'll be big battery plants and it'll be volume related, not technology related.
Okay. Yeah. So the technology's almost reached the limitation. Is that the point here?
In my opinion, for NMC batteries, we're getting to the point where that's it, and it'll run that way for a while. And one of the reasons for this as well is battery plants are expensive.
Yeah.
Billions. What's going in now needs to pay back. So I think that will also drive stability.
Okay, great. Look, I mean, this is linking into what I wanted to get into next, which is the supply chain piece. What needs to change here so that we can start to meet that demand? Because demand is exploding, right, for electric vehicles. We've seen some failures in the UK with British Volt going under and what's happening there. So where's the supply chain challenged and how is it sort of countermeasuring against the problems that it faces?
There's two supply chains. One's the battery plants, and the big corporations are building the battery plants. The startups are the ones who seem to be having the challenge. If we take the UK we've only got one existing battery plant and one under construction. That is a Chinese-Japanese conglomerate who are putting that together. Yeah. We need at least 3 large battery plants to go forward. But on the other bit of the supply chain, it's not worthwhile people creating the product for the battery plants without the volume. So for 10 years, we've had a total volume of 2 gigawatt hours, or about 40,000 batteries. You're not going to build a supply chain for that. Once you've got 3 battery plants, 4 battery plants, people will start, and I've just seen an announcement today on Teesside, there's some people starting to make anode material. That's a new one for me. We got lithium hydroxide plants being built, possibly mining, but you need the volume to get the supply chain. And there's also the other aspect, which people have probably been reading, is that there's a socio-economic, political nervousness about where everything's getting processed.
Yeah.
And Australia and America and the UK are leading with other countries to try and move that supply chain.
Yeah, I mean, I wasn't necessarily going to get into this sort of the geopolitical conversations around the domination of China, for example, and everything that comes through those guys at the moment. But is there any way that the rest of the world actually competes with where China are in terms of their ability to produce at scale?
The answer is yes, but the challenge is that our industry in the West is extremely regulated. So one of the things universities like mine and other universities have to come up with is how can we green that supply chain and keep it viable. So for instance, the lithium hydroxide plant that I mentioned that's opening on Teesside, they want to run on hydrogen. They don't want to run on gas. It's never been done before. So we're trying in a very, very tight window, not only to make the vehicles and the batteries, we're trying to launch technology at scale that we've never done before.
And given the advancements that we see elsewhere globally, what does that mean to the consumer or the fleet manager that's got to go and buy a vehicle? What are the consequences of us not having the capability, if you say, at scale to produce our own batteries?
If we're talking about the vehicles that are made in the UK, by 2030, 80% of all new vehicles sold will be zero emission. Tailpipe emission.
Yeah.
So that's where we're going. It's really hard for fleet managers. I fully sympathise with them. There is product out there they can buy, there's product they can run now. That's not a problem. What I would say to the fleet manager is, if you think by waiting 2 years, I'm going to get a vastly different product, I don't think you'll get a vastly different performing product, you'll just get more products at the same performance. A fleet manager will have a cars, vans for how long? 2 or 3 years? Gone.
Three to 4, maybe.
Gone. Rapid charging these batteries for that period won't make much difference.
Right.
If I own the vehicle and I'm keeping it for 10 years, I'll do that. But lease cars that are coming in the system and out, they'll just rapid charge them. Because that's their business. They'll just rapid charge them. Empty, full, off. Empty, full, off. And we've seen taxis that have lived their life that way. And the batteries are more robust than we thought they were. But it's the behaviours of the fleet manager and the driver will just fill it.
So on this then, since we're touching on charging briefly, the consequences of rapid charging all the time, what are they on the life of the battery?
There's 2 challenges on this now. One is the chemistry has not been stable enough over the life that we've had commercially sold vehicles to know the answer to that. All right? What VW and others are posting is accelerated tests. And there was an accelerated test done in America with the Leaf. It did 7 kilowatt charging and rapid. There was a deterioration. Both deteriorated, but it was only about 6 or 7% difference.
Which is nothing in the grand scheme of things, right? Yeah.
Over 10 or 12 years, and if it was 100% rapid charge. So at the moment, my car is only high power charged.
Right.
And it will go from 20 to 100. Just because it gets left there and I go and get it when the app says it's full. I don't hang around for it. A lot of private people are doing that.
Yeah.
But they're on a PCP or a 3-year where they're basically saying, well, it doesn't matter. It's not going to affect me in 3 years. I'll just get rid of it.
Yeah, sure. So it feels like there's more to understand on the sort of life cycle of a battery around charging and what happens, and certainly more to be discussed around education of how we use these
and
devices and behaviours. Yeah, which we're going to get into. I just want to come back to the topic of the technology of the battery and everything. I want to sort of point towards decarbonising. So it's commonplace to open the newspaper or to go onto LinkedIn, and EVs are touted as being no greener than their ICE counterparts, right? How true is that statement? There must be something in it because we hear so much about it, right?
No. The thing is that we refer to an EV, right? We don't refer to a petrol car, right? So you can compare my Zoe with a Rolls Royce, okay? Which one's the greener in manufacture? It's going to be the Zoe.
Okay.
Right? So if what we really have to do is compare a Clio with a Zoe, both made in France, both powered in France, and make the comparison. Mm-hmm. That's not what we do. Mm-hmm. So I can write a research paper which will tell you the answer to that way or that way. What do you want? The big energy thing on the battery is once you made the battery, you basically got to bake them.
Yeah.
About 10 days in a gas-fired ovens or electric, and that uses up the energy. If you actually take a vehicle and explode all the parts across this floor, 90% of them are the same. The carpet's the same, the headlight's the same, the tyres, everything is the same. It's the manufacture of the battery. Mm-hmm. That's where the comparison has to come in. But you have to do same car, equivalence car, made in the same country, with the same grid, the same power. If you take a large EV made in Poland and compare it with a small diesel made in France with a clean grid, you get different results.
Yeah, sure.
So you've got to read these to understand what the comparison is.
Okay, so the method of analysis needs to be consistent across the board is what we're saying here.
But the EV will get greener. No, the petrol car can't.
Yeah, so the technology that we've got today is suitable for most use cases. Seems like the obvious thing to actually say here is that most people could probably live in and get around and live their life in a battery electric vehicle if they could get one, of course.
If you live in a city, there is no reason why you can't. Mm-hmm. If you do a maintenance job or something and you're driving 200-300 miles a day, it may get irritating, especially if you live in the middle of Wales or you do something. So there are exceptions.
So just to try and sort of close the loop on all of this, and Colin, I know this is something close to your heart and that you like to talk about quite a bit as well. Circular economy for the technology of the battery in the vehicle. Yeah. Talk to us about that. Where is it today? What are the benefits of a battery electric vehicle? What are their second use second user examples that you can give us?
Well, whatever you put into a petrol car or diesel, you burn.
Yep.
It's gone. It's not reclaimable. EU legislation is coming out, and we'll forget about Brexit and others, but the vehicles are made for markets, okay? The battery has to have, by a certain point, percentages which are being defined for lithium, cobalt, manganese, nickel, replaced. So you can't sell a new battery unless it has a percent of the renewable in, all right? Fortunately, the minerals themselves don't degrade. It's the battery that degrades, all right? Where we are now is that we do not have, because people are driving 120,000 miles, we do not have the volume of batteries to recycle. Okay. We simply don't have them. And the other difference is when my battery comes out the car, it goes for energy storage. So it has a second life. We're still working out how long that second life is. Then we break it down. That second life also reduces the carbon emissions because it supports the grid. So those figures are not always taken into that other discussion we had. So we are looking now at how we actually extract those key materials out. This is where also comes into play world markets. Mm-hmm. So if you have a battery with a chemistry which is really high in cobalt and the price of cobalt's high, brilliant, that's a recycling industry, you can take that out and we know what we're doing. Yeah. The challenge comes, and this is something we've got to look at in economics, if it's an LFP, lithium iron phosphate battery, there's not the value in the recycled battery that there is in NMC.
Okay.
All right? So what we don't want is those batteries just getting sidelined. So the regulation has to cover those as well. So we're seeing the big recyclers that recycle cars and trucks now saying what we're going to do with batteries. And if you just bear with me, one of the things they want to do, the easiest way is you shred them. If you shred them, what you get is the equivalent of a coffee jar of what's known as black mass. It's literally like a coffee jar full of granules. That black mass has got an undefined mix of valuable and non-valuable things in. It's how you extract them out the black mass is the challenge. So I work as well, I've got the badge with the Faraday Institution. They've got a program on lithium recycling, and what we're doing is working with the recyclers and the laboratories to work out how do we actually get these back out in a viable commercial way, knowing that we have to do it anyway. But it started and it's happening, and I believe Northvolt have actually made a new battery with recycled material.
Okay, so it's happening. We're starting to understand how to recycle batteries from electric vehicles. Peter, I'll turn to you for a moment if that's okay, and probably ask the same questions and see where we get with this. So Colin and I started talking about density and cost. In the context of alternative energy, what's the story there for alternative energy in the industry that you're working in?
So we're going to have to break that down into separate products.
Yep.
But if we start with natural gas powered vehicles, what are commonly called CNG vehicles, then the key there is to operate them on biomethane. Biomethane is generated from anaerobic digestion and is collecting the methane that would come from rotting products, from food waste, from animal waste, and in some cases from crops, although that is less popular to do that. So you generate that methane, you then separate off the carbon dioxide, and you can use that. That's another saleable product. And without you've got to separate the carbon dioxide anyway, but if you were to release that, you would say it was carbon neutral. If you go to collect that carbon dioxide and use it for another source or another application, then you could actually say it's a carbon neutral fuel, or negative fuel rather. Okay. And then the transport would be to the point of use, and then you're then looking at how you store that gas on board the vehicle. Both North America and Europe have taken a common standard. It's an ISO standard, which allows you to store the gas on board the vehicle at either 200 bar or 250 bar. And that's determined by the type of tank that you've got on the vehicle. So the higher pressure are much lighter tanks. They've either got an aluminium liner or a polythene liner, and then they are wrapped in carbon. And the advantage there is you can get that additional range out of the vehicle. Now there is another big consideration. In Europe, most truck manufacturers build their own engines. And so the leading players in Europe are Iveco and Scania as far as gas trucks are concerned. If you go to North America, the market is very different. Most truck manufacturers there, sweeping statement, will buy in their engines. So you can buy a truck there with just about any brand of truck running on natural gas. And the other big advantage they have is they're deregulated in the length of the tractor unit.
Okay.
So it's possible to get a lot more gas on board the vehicle.
This is why we see these mega trucks in places like Australia as well, then, is it? These huge juggernauts.
Interestingly, the load they carry isn't actually any more than it is in Europe.
Oh, really? Right.
But the availability of space. So in Europe, we would traditionally load something like 100 to 120 kilos of gas per vehicle fill. You go to North America and it could be over 400 kilos of gas. Okay. So range is less of an issue.
So that distinct advantage then in terms of where battery technology is from that perspective for the heavy duty sector, right?
Yes. And it's very typical for a tractor unit. It could be after second, third ownership to be done close to 1 million miles.
Okay.
And so all the components on there will last that long, and refueling can be as quick as it can with a liquid fuel.
Yeah. So then let's bring this into the supply chain question that we asked Colin as well. What are the limitations around this as well? Is that challenged, or is it sort of readily available and easy to produce and distribute, or is there hurdles to overcome there, should we say?
So again, it's the traditional chicken and egg. You've got to have a market that demands the vehicle for the manufacturers to build them, because they're not going to make them in ones or twos. There needs to be a volume market there.
Yeah. And
certainly in the UK, we've seen a move of the supermarkets to take on board gaseous vehicles, either in the form of LNG or CNG, because they can immediately declare a carbon saving. Mm-hmm. And that's required to sell to their customers, and it's required because they need to declare that as part of their published annual report.
Okay. Yeah.
We will get to a degree of net zero for transport, not zero, right? I think we've got to be absolutely honest. For some circumstances, it will be petrol, it will be diesel, right? A tank is not going to run on biomethane, and a tank is not going to be CNG and there are some big vehicles which you see on construction sites, etc., or on the motorway, and it's going to be that much impact on the big impact. And we're just going to have to say, that's it.
Okay, great. Thanks very much, chaps. Thanks, guys. Thank you for joining us for the podcast, and thanks to our guests, Professor Colin and Peter Crowe. And we'll see you on the next one.